Session, we are going to look at the proof of the sum or difference rule. We already know or have established that if f and g are both differentiable functions, then the derivative of these two differentiable functions is given as this. Now we are going to use the first principle to help us prove this very rule. So to start with the sum of two functions, we know that the first principle is given as this. So what we are going to do is we find our f at x, we find our f at x plus h. So from here, our f at x, let's denote it by capital F. So capital F at x is given as small f at x plus g at x. And then our capital F at x plus h will be what? Will be f at x plus h plus g at x plus h. So what we are going to do is we are going to substitute this into the first principle formula and then see what we are going to get. So we know that the limit as h approaches 0 of f at x plus h, which is this one, so we are getting f of x plus h plus g at x plus h, and then we move on to f at x, and we know that our f at x is equal to this minus f at x plus g at x, and all this is over h. Now what we are going to do is to break up this function into the pieces of functions of f and then functions of g. So let's break it into functions of f and g. So we have the limit as h approaches 0. So we have f here, f at x plus h, and then we have f here. So we are going to get minus f at x, and then the next one too, we are going to get g at x. So we have plus g at x plus h. So this will give us minus g at x, and then let's call this one over h, and then this one too over h. Now let's apply the limit on each of them. So we have the limit as h approaches 0 of f at x plus h minus f at x all over h plus the limit as h approaches 0 of g at x plus h minus g at x all over h. Now what can you observe here? Now we can observe from this very part that this is the first principle of the first derivative of the function f with respect to x. So we can write this as f prime at x. Now what about this one too? We can also observe that this is the first derivative of first principle of the function g with respect to x. So we can write it plus g prime at x. And this is the derivative of sum of two functions. Now the proof of the derivative of difference of two functions is nearly similar to that of the derivative of sum of two functions. So we are not going to waste much time on it. We are just going to brush through. So in using the first principle, we know that we have to find our f at x plus h and then our f at x. So let's call our f to be capital F of the function x. So we are going to get f at x minus g at x because we are talking about a difference of two functions. And then our f at x plus h, that is the capital F, is going to give us small f at x plus h minus small g at x plus h. Now we are going to substitute this back into the first principle, and we are going to get the limit as h approaches 0 of f at x plus h minus g at x plus h minus, and then we have our f at x, which is this f at x minus g at x all over h. So the next step is we are going to break this into the function of f and then function of g. So we are going to get the limit as h approaches 0 of f at x plus h, then we have minus f at x, let's make it all over h, and then we have minus g at x plus h. This was giving us plus g at x all over h. Now let's factorize the negative out so that we are going to have the limit as h approaches 0 of f at x plus h minus f at x all over h. Let's take the limit too. So we have minus the limit as h approaches 0. We are going to get g at x plus h. We factored the negative first. We are going to get minus g at x all over h. Now what can you observe? We can observe that this is the first principle of the first derivative of the function f. So we can write it as f prime at x. We have the minus here, and this is also going to give us what g prime at x, and this is the derivative of difference of two functions. So we said that So we are done with the proof. Thanks for watching. Make sure you subscribe to this very channel for more updates.